We can interpret the definite integral as the area between the curve and the x-axis. So for this problem, I can think about drawing the curve and then examining one part of the x-axis. How do I know which part? Well, this dx, the x tells me that I'm going from x equals -4 to x equals 0. So I'm going to start this by saying let's go the x-axis from x equals -4 to x equals 0. I'm interested in this region of the x-axis. So first I label my x-axis. Now I have to come in and say, well, what's my curve? My curve is y equals the square root of 16 minus x squared. Now, there's a trick to this. This is actually the equation for a circle. Let's do a few things to see that. So I'm going to square both sides, and I'll end up with y squared equals 16 minus x squared, rearranging x squared plus y squared equals 16. Now, I can recall here that the standard form of a circle, x minus h squared, y minus k squared equals r squared, where the center is hk and the radius is just r. So going back here, this is x minus 0 squared plus y minus 0 squared equals 4 squared. So I have a circle with center 0, 0 and radius equal to 4. So I can draw, roughly speaking, center 0, 0, pretend this is a good circle here. And then the question is, okay, well, the area between this part of the x-axis, am I going to take the upper region or the lower region? And in this case, when I look at my original integrand, we assume that there's a positive in front. If I had the positive in front, then I'm looking for this region. If I had had a negative in front, then I would have been looking for negative below the x-axis. We'll interpret as negative area. So I can have a visual representation of this integral. I'm going from -4 to 0 on the x-axis, and I'm taking the area between the curve and the x-axis. If it's positive, it's above the x-axis. Negative, we'll think about as below negative area. So that was a visual representation. We could also go ahead and find the exact area. So I want to know the area, in this case, of 1/4 of a circle. So I can interpret this as the area of 1/4 of the circle. So this, we know that area is pi r squared. In this case, our radius is 4, and I want to take 1/4 of that. So this will be 1/4 of pi r squared, and I could go ahead and simplify this to just be 4 pi. If I had had the region below the x-axis, I would make it a signed area and go with a negative sign there.